Welcome to section 2.5. We're going to be talking about zeros of polynomial functions. Now, a polynomial function has at most n real zeros, and n is that degree. So keep that in mind. Now, just because it says at most doesn't mean all of them are going to be real. And we'll be talking about those later on, especially we talk about complex solutions, those imaginary solutions. Now we're going to find the zeros. So once again, the zeros are the x-intercepts, the values of x that make y equal to 0. So 0 equals x minus 2. So when we solve, we get x equals 2. There's a 0. 0 equals, and we can factor this. When we factor x squared minus 6x plus 9, we get x minus 3 squared. So set the factor x minus 3 equal to 0, so x equals 3. Now, that solution is being repeated twice. It's got that multiplicity of 2. For 3, 0 equals, and we can factor out an x. X times x squared plus 4. Set x equal to 0. X squared plus 4 equal to 0. X squared equals negative 4. And when we take the square root of both sides, we get x equals plus or minus 2i. So x equals 0 and x equals 2i and negative 2i. Those are our three zeros. Notice degree 3. 2 of them were imaginary zeros. Now for problem number 4. 0 equals. Now this is a polynomial in quadratic form. X to the fourth is a perfect square and so is 1. When we factor this, it's actually going to be x squared and x squared for our first terms, and our last term is a 1. So it's a plus 1 and a minus 1. X squared plus 1. And we can factor x squared minus the 1 to be x plus 1, x minus 1. So set the factors equal to 0. X squared plus 1 equals 0. X plus 1 equals 0. X minus 1 equals 0. So those solutions are x equals negative 1, x equals 1. X squared equals negative 1, take the square root, x equals plus or minus I. There's our 4 zeros. Notice 2 of them are imaginary. Now, the rational zero test talks about the possible rational zeros, and we're going to use this to help us factor and to help us solve these. Now, to do that, it's the leading coefficient, the factors of the constant, over the factors of the leading coefficient, P over Q. Now, let's see this in action. Now, the possible are going to be the factors of the leading coefficient, the constant over the factors of the leading coefficient. P over Q, that's A sub 0 over A sub n. You might see it both ways. So the factors of the constant, 3, could be a plus or minus 1, a plus or minus 3. The constant is 2, so the factors of the leading coefficient, plus or minus 1, plus or minus 2. Sorry, I can't talk today. So now when we divide the numerators by 1, we could have a plus or minus 1, a plus or minus 3. Then we're going to divide them by 2. So it's a plus or minus 1/2 and a plus or minus 3/2. Those are our possible rational zeros, those possible real zeros. So now what we're going to do is we're going to check to see which ones work. We can use this, and I'm going to see, all right, is my negative 1 going to work? Can x equal negative 1? So I'm going to do my synthetic division. I'm going to put negative 1 on the outside, and then 2, 3, negative 8, and 3. I'm going to do my synthetic division. Bring down the 2. Negative 1 times 2 is negative 2. When I add, I get a 1. Negative 1 times 1 is negative 1. And when I add, I get a negative 9. Negative 1 times negative 9 is 9. I get a 12. That didn't work. I need my remainder to be 0. So I'm going to try a positive 1. 1 goes on the outside. 2, 3, negative 8, and 3 go up top. Bring down the 2. 3 times 2. 1 times 2 is 2. Add, we get a 5. 5 there. -3, -3, remainder of 0. That did work. And we knew it worked because our remainder was 0. Now, our first factor is x minus 1. We subtract the 0 from x. So f of x equals x minus 1. And now, from our division, that was x cubed up top, so x squared. So it's 2x squared plus 5x minus 3. Now, you could keep trying different values, but once you get to the quadratic, factor the quadratic. X minus 1. And then when you factor this quadratic, 2x and x, to get to positive 5, we're going to have a 3 over here, a positive 3, and a negative 1. Set the factors equal to 0 or solve them. You get x equals 1, x equals 1/2, and x equals negative 3. Those are our zeros, our rational zeros, our real zeros. Now, for problem number 6, find the rational zeros of this. Now, the possible. A sub 0 over A sub n, that P over Q. The factors of the constant over the factors of the leading coefficient. The factors of the constant 1 are just plus or minus 1. The factors of the leading coefficient are plus or minus 1. So our possibles are just plus or minus 1. Those are the only two possibilities we have. Let's try the 1 first. 1 goes on the outside. And on the inside, 1, 0. We need that placeholder, 1, 1. Bring down the 1, 1. Add, we get a 1, a 2, a 2, remainder of 3. That's no good. That didn't work. X equals negative 1. Let's try that. 1. Bring down the 1. Sorry, negative 1's on the outside. Negative 1. 1, 0, 1, 1. Got ahead of myself. Negative 1 times 1 is negative 1. Negative 1. 1, which gives us a 2. Negative 1 times 2 is negative 2, which is a negative 1. That didn't work either. Neither of our possible rational zeros worked. So that means there are no rational zeros for this. Our zeros are a different type of number. They must be irrational. So we can't do anything with it. Number 7. We're going to find the real zeros. So for this, the possible. A sub 0 over A sub n, that P over Q. The factors of the constant, plus or minus 1, plus or minus 2, plus or minus 7, plus or minus 14, over the leading coefficient of 1 plus or minus 1. So our possibles are plus or minus 1, plus or minus 2, plus or minus 7, plus or minus 14. We have 8 possibilities that may work. What you would want to do is you would want to graph this. And when you graph it, you'll find out that one of the x-intercepts is at negative 2. Instead of going through and checking in all of these and seeing what works and what doesn't work, we can look at the graph and say, all right, it crosses the x-axis at negative 2, and that's where we're going to start, negative 2. So negative 2 goes on the outside, and on the inside, 1, negative 7, negative 11, and 14. Bring down the 1. Negative 2 times 1 is negative 2. When you add, you get a negative 9. Times negative 2 is a positive 18. Add, you get a 7. Times negative 2 is negative 14, and remainder of 0. It worked. So now, f of x equals, when x equals negative 2, our factor is x minus negative 2, which is x plus 2. So the first factor, x plus 2, and then we're left with x squared minus 9x plus 7. Once you get down to the quadratic, factor it if possible. This quadratic is not factorable. So x equals -2. And then we're going to set x squared minus 9x plus 7 equal to 0. We can't factor this quadratic. Since we can't factor it, we'd have to use a different method, either quadratic formula or, or we could use the quadratic formula or completing the square. With this one, because of the 9, I'm not going to use quadratic. I'm not going to use completing the square. X equals the opposite of b plus or minus the square root, b squared minus 4ac, all divided by 2 times a. The opposite of -9 is 9, plus or minus the square root. -9 squared minus 4 times 1 times 7, all divided by 2 times 1. So x equals 9 plus or minus the square root of 53, all divided by 2. So x equals -2, and x equals, I'm going to split them up, 9/2 plus or minus the square root of 53 over 2. There's our 3 solutions. One of them is rational, the other 2 are irrational, for a total of 3. So once you get down to the quadratic, you have to use a different method. Let's go to the next page, please. If you notice with our irrationals and even our complex, they always come in pairs with the complex conjugate. So whenever you have an irrational or a complex 0, its conjugate is always included. Always in that a plus b, a minus b, or a plus bi, a minus bi. So if you look at our problem number 8, we have a 4th degree polynomial with real coefficients of x's are -1, -1, 3i. So if 3i is a 0, its conjugate -3i is a 0. So f of x equals, always subtract your zeros from x minus -1, x minus -1, x minus 3i, x minus -3i. So we clean that up. F of x equals x plus 1, x plus 1, x minus 3i, x plus 3i. So we're going to multiply these in pairs. I'm going to multiply the x plus 1s. It's x plus 1 squared, so it's going to be x squared plus 2x plus 1. And these are conjugates, so it's just going to be x squared minus 9i squared. So it's x squared plus 2x plus 1, and then it's going to be x squared minus 9 times -1, which is a positive 9. So it's x squared plus 9. So now I distribute my x squared and my 9. F of x equals x to the 4th plus 2x cubed plus x squared. Distribute the 9, so plus 9x squared plus 18x plus 9. So when I combine, f of x equals x to the 4th plus 2x cubed plus 10 x squared plus 18x plus 9. And there we go. Now for the last one, problem number 9, and we'll catch up with the other ones tomorrow. We have our zeros of 2, 1 plus 4i. So if 1 plus 4i is a 0, we need to include 1 minus 4i. So we're always subtracting it from 0, x minus 2, x minus the quantity of 1 plus 4i, x minus the quantity of 1 minus 4i. So you have x minus 2, x minus 1 minus 4i, x minus 1 plus 4i. Always multiply those ugly trinomials first. I'll show you two different ways to do it. First way is the long way. Distribute the x, the negative 1, the negative 4. So you get x squared minus x plus 4ix. Distribute the negative 1, so minus x plus 1 minus 4i. Distribute the negative 4i, so minus 4ix plus 4i minus 16i squared. Now, the 4ix's cancel, the negative 4i's cancel, and that negative 16i squared is negative 16 times negative 1, which is a positive 16. So f of x equals x minus 2, and then you get x squared minus 2x, and 1 plus 16 is plus 17. And there we go. We just multiplied. Now, if you want to do that another way, x minus 1 minus 4i, x minus 1 plus 4i. You could group together the x minus 1 and the 4i's. So that would be a and b, a and b. They're conjugates. So you get x minus 1 squared minus 4i squared. So it would be x squared minus 2x plus 1 minus 16i squared. So you get x squared minus 2x plus 17. You see you get the same answer there. Just different ways to do it. Distribute the x, you get x cubed minus 2x squared plus 17x. The negative 2, you get negative 2x squared plus 4x minus 34. So you get x cubed minus 4x squared plus 21x minus 34 when you combine your like terms. And there you go. We'll finish up this section in the next video. Thank you.